Solving equations transformable into quadratic equation. Our objective is at the end of this lesson, we should be able to solve equations transformable in quadratic equation. Remember, there are equations that can be transformed into quadratic equations in the form ax squared plus bx plus c equals to 0, where a, b, and c are real numbers and a is not equal by 0. Some examples of this type of equations are rational algebraic equations. Example number 1. X times the quantity x minus 6 equals 16. This is an example of quadratic equation that is not written in the standard form. Let's transform the given equation into quadratic equation. First, we must find the product of x and x minus 6. To get the product of x and x minus 6, just simply distribute x one by x and negative 6. Therefore, we have x times x is x squared, x times negative 6 is negative 6x equals 16. Since the given quadratic equation is not in the standard form, let's write it on the standard form. By the means of addition property of equality, we will be adding both sides of the equation by negative 16. That's why the result is x squared minus 6x minus 16 equals 0. We will use factoring since the given is factorable. The factor of the following quadratic equation x squared minus 6x minus 16 equals to 0 is x minus 8 times the quantity x plus 2 equals to 0. The next step is apply the zero factor property, meaning let's equate both factors by 0. That's why we have x minus 8 equals to 0 or x plus 2 equals to 0. By means of the addition property of equality, x becomes 8 or x equals negative 2. Example number 2. The quantity x plus 3 squared plus the quantity x plus 2 squared equals 5. This is again an example of a quadratic equation that is not written in the standard form. As you notice, we can expand this as x plus 3 times x plus 3. Same as in this part, we can expand this as x plus 2 times x plus 2. Or the easiest way in expanding the quantity x plus 3 squared and the quantity x plus 2 squared is by the use of the square of binomial. So remember the square of binomial. The first step is to square the first term. The second step is to twice the product of the first and second term. And the third one is to square the second term. Now, in this case, as we apply the steps in given x plus 3, again, this is your first term and this is your second term. Let's have square the first term. That means x times x, we have x squared. Next, number 2, twice the product of the first term and second term. Just simply multiply the first term and second term and multiply it again by 2. That means x times 3 is 3x times 2, that is 6x. Since the operation between the binomial is addition, therefore, we will be having addition also. That is positive 6x. Third, square the second term. Meaning, let's multiply 3 by itself. 3 times 3 is 9. Always remember that your first term and the last term of the given trinomial will become positive. The middle term or the second term will depend on the sign of your binomial. Then let's have plus. Let's apply this again. Square the first term. X times x is x squared. Twice the product of the first and second term. X times 2, 2x times 2, we have 4x. 2 times 2, we have 4. Equal by 5. After expanding the binomials, let's combine similar terms. So we have x squared plus 6x plus 4x plus 9 plus 4 equals 5. Simplify the given terms. X squared plus x squared is equal to 2x squared. 6x plus 4x is equal to 10x. 9 plus 4 is equal to 13, equal to 5. Again, since the given quadratic equation is not in the standard form, we must transform it into standard form. Let's move positive 5 to the other side of the equation. That's why we have 2x squared plus 10x plus 8 equals to 0. Remember, as we move 5 to the other side, it will become negative. That's why 13 minus 5 is equal to 8. Since the given quadratic equation is factorable, let's factor it. Quantity 2x plus 2 times the quantity x plus 4 equals to 0. Equate both factor by 0. So the result is 2x plus 2 equals to 0 or x plus 4 equals to 0. To solve 2x plus 2 equals to 0, we must move positive 2 to the other side of the equation by the use of the addition property of equality. That's why the result is 2x equals negative 2. Since we still have 2 as the numerical coefficient of x and we need to cancel it out, let's divide both sides of the equation by positive 2. 2 and 2 here will be cancelled out. That's why we have x equals negative 2 over 2 is negative 1. For x plus 4 equals to 0, just simply move positive 4 to the other side of the equation by the use of the addition property of equality. That's why we have x equals negative 4. Example number 3. 2 times the quantity 3x minus 2 squared plus 5 times the quantity 3x minus 2 plus 3 equals to 0. For this kind of question, we must simplify first the quantity 3x minus 2 squared and 5 times the quantity 3x minus 2. In this case, we will be using the square of binomial. That's why we have 2 times 9x squared minus 12x plus 4 plus, for this part, just simply distribute 1 by 1, 5 by 3x and negative 2. That's why we have positive 15x minus 10 plus 3 equals to 0. The next step is to distribute 2 1 by 1 to each term of the given trinomial. That's why we have 18x squared minus 24x plus 8 plus 15x minus 10 plus 3 equal to 0. Then let's combine similar term. Let's just simply bring down 18x squared. Negative 24x is similar to positive 15x. Positive 8 is similar to negative 10 and positive 3. Then equate it by 0. Simplify. Copy 18x squared. Negative 24x plus 15x is equal to negative 9x. Positive 8 minus 10 is equal to negative 2 plus 3 is positive 1, equal by 0. Since the 2 given is factorable, then let's factor. The factor of 18x squared minus 9x plus 1 equals to 0 is 6x minus 1 and 3x minus 1. Equate both factors by 0. So we have 6x minus 1 equal to 0 and 3x minus 1 equal to 0. Let's move negative 1 to the other side of the equation by the addition property of equality. That's why we have 6x equals positive 1. Let's eliminate the numerical coefficient of x, which is 6, by dividing both sides of your equation by positive 6. That's why the value of x is equal to 1 over 6. The second factor, 3x minus 1 equals to 0. Again, let's apply the addition property of equality. That's why we have 3x equals positive 1. Eliminate 3. That's why we divide both sides of the equation by positive 3. That's why x is equal to 1 over 3. Take note, in order to find the roots of equations transformable into quadratic equations, we must rewrite the equation first into quadratic equation in the standard form, and then apply any of the four methods that is most suited to get the roots. Thank you!